Now we will see question number 2. What is data imputation and how would you decide on the best imputation method for handling missing values in a large data set? Discuss the potential risk of using the mean value method and explain how the nearest neighbor imputation method works. Data imputation refers to the process of filling in missing or incomplete value in a dataset. It is a crucial step in data pre-processing, especially when working with real-world datasets that often contain missing values. Imputation aims to retain the integrity of the dataset while avoiding bias or loss of information due to missing data. There are several methods to handle missing values, and the appropriate method largely depends on the nature of dataset, the type of missing data, and the analysis or machine learning model you are using. Choosing the best imputation method requires an understanding of underlying nature of the missing data and the goal of your analysis. Here are some factors to consider. First, type of missing data. MCAR, missing completely at random. Missingness is unrelated to any unobserved or unobserved data. Imputation methods like mean, median imputation can work well. MAR, missing at random. Missingness is related to other observed data. In this case, methods like multivariate imputation or regression imputation may be more appropriate. MNAR, missing not at random. Missingness is related to the missing values themselves. This requires more complex approach like multiple imputation or model design to account for this type of missingness. Second, we have nature of the data, categorical or numerical. For numerical data, methods like mean imputation, median imputation, or k nearest neighbor KNN are often used. For categorical data, mode imputation, filling missing values with the most frequent category, or using predictive modeling might be more suitable. Impact on Third, we have impact on performance. Some machine learning algorithms like decision trees and random forest can handle missing values natively, while others like linear regression or SVM require inputted data. You may also want to assess how imputation affects model performance by evaluating various methods using cross-validation or other model evaluation techniques. Fourth, we have size complexity of dataset. Large datasets with a high volume of missing values may benefit from more sophisticated methods like k-nearest neighbors imputation or multiple imputation, which takes into account the relationships between multiple variables. Now we will see the potential risk of using the mean imputation. Using the mean imputation method, where missing values are replaced with the mean of the observed values for a particular feature, is one of the simplest approach. However, this method has several potential risks and limitations. First is bias in data distribution. Imputing missing values with the mean distorts the data distribution if the data is skewed. Replacing missing values with the mean can reduce the variance and cause the data to become overly symmetric, potentially misleading model predictions. Second, we have underestimation of variance. Imputation using the mean reduces the overall variance in the dataset, making the data appear less variable than it actually is. This can affect statistical test confidence intervals and machine learning models that rely on variance. Third is assumption of missingness. The method assumes that the missing value are missing completely at random MCAR and the data is missing at random MAR or missing not at random MNAR. Mean imputation can introduce bias and lead to incorrect conclusions. Fourth, potential loss of relationships. By replacing missing values with mean, you lose the natural variation and relationships between variables, potentially leading to a poorer model fit and predictive accuracy. Now we will see how nearest neighbor imputation works. The nearest neighbor KNN imputation method is more advanced technique that uses the proximity between data points to estimate missing values. Here we will see it's working. First, identify similar data points for each instance with missing value. The KNN algorithm identifies k nearest neighbor, the most similar row based on other features in the data set. The similarity is typically measured using distance metrics like Euclidean distance or cosine similarity. Second, we have impute missing values. Once the neighbor are identified, the missing values is imputed by averaging the corresponding values from the k nearest neighbor for numerical data or taking the mode for categorical data. For numerical data, the missing value is imputed by average of the value of the k nearest neighbor for the feature. For categorical data, the missing value is imputed by the most frequent category among the k nearest neighbor. Choice of k, number of neighbors. The choice of k is crucial. A very small k may lead to noisy imputation, while very large k may smoother valuable details. Cross validation can help to choose the optimal k value for a specific dataset. Now we will see its advantages. KNN imputation can be more accurate than mean imputation, especially when the missing data is related to the other variables. It can preserve the relationship between features and the structure of the data better. It, it works well with datasets where similar patterns are expected for missing values. Now, what are its disadvantages? KNN imputation can be computationally expensive, particularly for the large datasets, because it requires calculating distances between every pair of data points. It may not perform well when the dataset contains many missing values or when there are many irrelevant or noisy features. The method requires careful tuning of the k parameter, and performance can degrade if the dataset has highly dimensionality. Thank you. This is all for this video.